What's up, everyone? Welcome to this lesson where we're going to explore the different triangle congruence theorems. So let's start out by asking the question, what does congruence even mean? We like to think of it as this equal sign with the squiggly line over it, but let's just take a few moments to really conceptualize what congruence means, especially in terms of figures. So let's look at a running shoe. If I can somehow duplicate this running shoe and make an exact replica, I would say that these two shoes are congruent because they are exactly the same size and shape. Now, even if I change the color of one of the shoes or I rotate it around a certain number of degrees, it's still congruent to the original sneaker because it's the same size and shape. And we want to extend this kind of thinking now to comparing triangles to see whether or not they are congruent. If their corresponding sides and angles have the same measure, then we can say that the triangles are congruent. And this applies even when the figures don't have the same orientation, and visually it's not so easy to tell whether or not these triangles are congruent, and this is where our theorems are going to come into play. So the goal of this lesson is to help you to understand why the theorems that we use prove congruence and how to know which theorem to use in a particular situation. So here are the 5 triangle theorems with their abbreviations. We have side, 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 angle, angle, side, angle, angle, side, and hypotenuse leg. So now we're ready to go ahead and explore each theorem individually. Now the side, side, side triangle congruence theorem states that if in 2 triangles we have 3 pairs of corresponding sides that are congruent to each other, that means that they have the same length, then that's enough information to say that the triangles are congruent to each other. Which again just means that both triangles are exactly the same size and shape. So in this instance, we can use the side, side, side theorem to conclude that the triangles are congruent and that their corresponding sides and corresponding angles have the same measure. And remember that this relationship is still true even if the figures have different orientation. Our next theorem is side, angle, side. Now for this triangle congruence theorem, we start with a pair of corresponding congruent sides in 2 triangles. We also have a pair of corresponding angles that are congruent and another set of corresponding sides that are congruent. Now see that the letter A is in between the 2 S's in the name of the theorem? This corresponds with that congruent angle being in between the 2 congruent sides. Now when this is the case, we have enough information to say that the 2 triangles are congruent by using the side, angle, side theorem. Our next congruence theorem is the angle, side, angle theorem. When we have 2 triangles with a pair of corresponding congruent angles, a pair of corresponding congruent sides, and another pair of corresponding congruent angles, we have enough information to prove congruence using angle, side, angle. Now it's important to notice that the congruent side is in between the 2 congruent angles. And now we can visualize that when this is the case, we have enough information to prove that the 2 triangles are congruent by angle, side, angle, which means that all of their corresponding sides and corresponding angles have the same measure. Now our next theorem is very similar to the one that we just looked at, which was angle, side, angle. This one is called angle, angle, side. Now when in 2 triangles, we have a pair of corresponding congruent angles, along with a second pair of corresponding congruent angles, as well as a pair of corresponding congruent sides. Now we don't want to confuse the last theorem, angle, side, angle, and this theorem of angle, angle, side, because both of them involve 2 congruent angles and 1 congruent side. The difference is that in angle, angle, side, the congruent angles are consecutive. That is, that they are one after the other. And then the congruent side is next to them instead of in between them. Now, even though the order is different, we still have enough information here to prove that these 2 triangles are congruent, which means again that their corresponding sides and corresponding angles have the same measure. Now our final congruence theorem is kind of a special case. It's called hypotenuse leg, and it applies to right triangles only. So let's start out with the key feature of any right triangle, and that is a right angle. Now we know that the hypotenuse of a right triangle is its longest side and is always opposite the right angle. So this congruence theorem says that if the hypotenuse in both right triangles are congruent, and if a leg, which is one of the other sides, are congruent, that is, they have a pair of corresponding congruent sides, then that is enough to say that the two triangles are congruent. Again, which means that the triangle's corresponding sides and corresponding angles have the same measure. So now that we've covered the 5 triangle congruence theorems, you may be asking, what about angle side side? Please don't be uptight. Okay, so now let's go ahead and explore why angle side side would not work as a triangle congruence theorem. So if we have a set of corresponding angles that are congruent and a set of corresponding sides that are congruent. Okay, so we have 2 sets. We have an angle followed by 2 consecutive congruent sides. The issue is with that second congruent side, since we don't know the angle in between the 2 congruent sides, we don't exactly know its position. So I could take that side and swing it over to a new location and still show that angle side side is still the case here, no matter how I choose to draw that second triangle. And I have the option of drawing it either way, since that's an isosceles triangle, so both of those sides are definitely congruent to each other. Now if I draw it this way as an acute triangle, I see that I have angle side side, however, the base of each triangle clearly are not the same, and